In this video, we go over how to draw the graph shown in figure 314 on page 73. We follow the instructions in example 3.6c on page 93. First, we'll load a sound file. We want noisy wolf whistle. Let's listen to it. So I think you could hear a brief pop occurring right around here, and then the static random noise background there. So we'll use wavelet thresholding to denoise this signal. Transform wavelet, and we'll use a coif 18 wavelet. Transform here, we get this. Now to denoise that signal is rather complicated because we're going to threshold to get rid of the random noise, but also we want to get rid of things like this, which are due to the pop sound there. So we have a pre-computed denoising function that will do that. Now it's quite complex because it's doing different operations in the trend and in the various fluctuations. For example, when x is less than c, the length of the interval, the time interval, divided by 2 to the 15th, so that we're in the trend here is what this is doing for us. g1 of x times this statement here means that we're restricting to the trend, the 15th level trend. There we're just keeping g1 of x. For the fluctuations, for the 15th level fluctuation through to the 4th level fluctuations, we're thresholding by a threshold given by t there, and t is shown down here, 2.98. But on other thresholds, other fluctuation levels, from 4th to here we're in the third fluctuation level here. We're using a band thresholding, and then throwing away things that are above 67 in magnitude, for the values above 67 there. And u is absolute value of g1 of x. So if the magnitude of g1 of x, the transform, is above 67, we're going to actually throw that away. So this will denoise this combination random noise plus pop noise signal. Let's plot this. And then let's look at the denoised transform itself. There. And notice it's gotten rid of things like this spike here, which is due to the pop noise, and also got rid of the random stuff in the transform from the random noise in the signal. So now let's see how successful this was. We're going to invert, keep the same wavelet type. Now we get that signal. Let's copy that, go back to the original signal and paste in. And now let's listen to the two together. First the noisy signal, then the denoised signal. It got rid of a lot of the random noise, some of the windy sound, It's questionable whether one regards that as noise or not. It's the sound of my whistle blowing onto the microphone, kind of a wind sound. So that's quite difficult to remove. We got rid of most of the random static and certainly the pop noise. Let's listen one more time. Little remnants of the pop noise, but it was a very noisy signal, and this simple thresholding, adapted thresholding, denoising did a decent job on it. Thank you for watching.